All right, friends. So I want to do another practice problem with you um, where we think about what would happen if we could take a Snickers bar. So bear with me. I love Snickers bars, so going with that. Take a Snickers bar, and we actually could find a way to catch that thing on fire. So we're going to light the sucker on fire, let it burn, and measure then in a calorimeter of some sorts. Remember, a calorimeter is just a thing that we use to measure the amount of energy, often in food. But honestly, you could use this for measuring energy in gasoline or anything else, anything that we could light on fire, which is a lot of things. Um, we fill this with some sort of substance that can heat up pretty slowly. Usually that's water. We've got our thermometer up here that's measuring temperature. And we want to see what happens. What do we do when we heat up this Snickers bar? So what do we need to know? I'm going to pause there and let you think about that. All right, you probably know now what we need to know. One thing we need to know is how big is our Snickers bar? So according to the internet, a standard Snickers bar is about 44 grams. And if you look up the nutritional information, it has about 215 food calories, big C calories, which remember is really 215 kilocalories. All right, so let's say we take this thing and we light it on fire. Now, Snickers bars don't actually burn very easily, so we'd have to figure out how to deal with the water in it. But we have it light on fire. Let's say our water temperature starts over here at a nice room temperature of about 20 degrees. No, let's go with 22 degrees Celsius. That's pretty normal. And it burns for a while. And let's say that our end temperature, it really heats up our water, about 33.8 degrees or something like that. Now, the question is, what else do we need to know to fill out our equation here? Remember, this mass, this M represents the mass of the water, the substance that's being heated up, in this case, water. So I need to tell you that. Let's say that we had 2 liters of water, which you may not know is 2,000 milliliters. And if you remember that, you would remember that 1 milliliter is the same as 1 gram. So that's like 2,000 grams of water. So based on what I have right here, you can now calculate Q. Q is the amount of energy absorbed by the water. So now I'm going to pause a little bit and let you do that. Now, obviously, you probably had to hit the pause button there and do some number crunching. So here's what we get if I put these numbers in. So my mass, again, of the water, 2,000 grams. The heat capacity of water is 1. The triangle T, remember that's delta T, that's a change in temperature, so that's 11.8 degrees Celsius. And so I think, I should put a grams there, I think that ends up, if I do this number crunching right, at about 23,600 calories, little c calories, or 23.6 kilocalories. Now, can I compare these two directly? I hope you said no. No, I can't compare them directly. Because up here, this top one, that's 215 kilocalories in 44 grams. The bottom one is 23.6 kilocalories in, oh, how many grams? Oh no, we don't know. Because what I didn't tell you is this is the starting temperature of 44. Let's assume that not all of it burns, because it rarely does. Let's say the end temperature is 20 grams. So that means we've only burned 24 grams of Snickers were burned. So now we have to be able to use this number, how much of the Snickers was burned, to figure out down below what is our energy per gram, our kilocalories per gram of Snickers burned. So if I do 23.6 kilocalories divided by 24 grams of Snickers, that's less than 1. It's about 0.98 kilocalories per gram. Well, now we need to be able to compare that to the one up above. Where one up above said, and this is our our actual numbers, the numbers that we measured. So actual value. So if I look up above, remember I said it's 215 kilocalories in 44 grams. And that works out to a much bigger number. It's like 4.89 kilocalories per gram. And that's our theoretical value. That's like in a perfect world, that's what we would get. So then the last question we often ask is, okay, so we did this experiment. To recap, in our experiment, you took 44 gram Snickers, lit it on fire, 24 grams of that Snickers bar burned. During that time, that 24 grams of combusting Snickers bar raised the temperature a total of 11.8 degrees. And that was 2 liters of water. So then we could calculate that 2 liters of water with an 11.8 degree temperature change absorbed 23.6 kilocalories. And since we combusted and absorbed 23.6 kilocalories from 24 grams of combusted bar, so this is energy absorbed, for 24 grams of bar burned, we can calculate an actual value of 0.98 kilocalories per gram. We look on the label of a Snickers and it says actually there are 215 kilocalories in 44 grams of a Snickers bar, so there we get our theoretical value. And then we can do our final calculation with it, which is to say, all right, if I take my actual and divide by theoretical, so that's 0.98 kilocalories per gram, divided by 4.89 kilocalories per gram, and I multiply by that by 100, I get a percent. That is like my percent accuracy. And if you do that, it's about 20% with these numbers. So that tells me that my system was pretty leaky and pretty messy in terms of energy. That when this thing was burning, only about 20% of the energy being released went into the water. The other 80% was going in all different directions.